So we're doing chapter 7, and we're going to start off with practice A, problem number 4. So we're going to write our given, and we're going to write our find like we always do, because that's going to help us to problem solve if we're not sure what to do. So it says a race car is moving along a circular track, so we know it's going on a circular track. And it has a centripetal acceleration of 15.4 meters per second squared. So the centripetal acceleration is 15.4 meters per second squared. So if I just pick an arbitrary point, I don't know if it's going clockwise or counterclockwise. Again, the tangential velocity is perpendicular to the centripetal acceleration. If the car has a tangential speed of 30 meters per second, what is the distance between the car and the center of the track? Well, the distance between the car and the center of the track, that's the radius of the circle. So again, sometimes if you draw a tiny picture, we can conceptualize that. Right? All right, so where do I start? First, what I'm going to do is I'm going to say, what's the relationship between centripetal acceleration, tangential velocity, and r? So the equation is centripetal acceleration. Now remember, this is a subscript, a subscript little c, is equal to vt squared over r. Now, I want to solve for r. So what I'm going to do is I'm going to rearrange the equation to solve for the unknown in terms of the known. I'm not going to plug in my equations because when I start plugging stuff in, that's where I make mistakes. So first, I'll multiply both sides by r. Now, everyone doesn't have to do this. Everyone has a different math level. Then I'm going to divide both sides by a. So when I rearrange it, r is equal to vt squared over ac. Now I'm going to substitute in my values 30 meters per second squared over 15.4 meters per second squared. Now remember, in physics, we have a foolproof way to check our work every time. Okay? So let me look at my units first. When I square the 30, I have to square my unit. So I'm going to have meter squared over second squared divided by a meter per second squared. If you have a hard time with your units like that, just do it on the side. So a meter squared over a second squared times. So remember, when I divide fractions, it's like multiplying times the reciprocal. So when I do that, these two cancel, and this cancels with that, and I end up with meters, which is the correct unit for the radius. And it comes out to be 58.4 meters. So we always want to carry our units through and cancel to check our work. All right, now we're going to look at 7b, and we're going to look at number 4. So again, we're going to write our given, and we're going to write our find. And when I read the problem, I'm going to chunk. I'm not going to read the whole thing and get confused. I'm going to read, I'm going to write, I'm going to read, I'm going to write. So it says a 905 kilogram car. So kilograms is the mass. Travels around a circular track with a circumference of 3.25 kilometers. So the first thing I'm going to do is I'm going to write what I'm reading. Circumference is 3.25 kilometers. Now, I know I don't want to do stuff in kilometers. So what I'm going to do is I'm going to convert, I'll do it right off, my kilometers to meters, 3250 meters. Kilo is a prefix that means 10 to the 3, so I just moved it over 3 places. Now, thinking about it, I know none of my equations have circumference. So I'm going to say to myself, what do I know about circumference? What is circumference? Well, I know circumference is equal to 2 pi r. And I know that I'm going to end up needing the radius. So what I'm going to do is I'm going to rearrange this equation and say c over 2 pi is equal to r. And so 3250 meters divided by 2 pi is equal to r, and I'm going to go ahead and I'm going to calculate that. So when I do that, the radius comes out to be 517.5 meters, which I'll just round to 518 meters with my 3 significant figures. So I haven't even finished reading the problem. So instead of going through, as I'm reading it, I'm doing my conversion. What does circumference mean? And I'm writing that all down. The last part says if the magnitude of the centripetal force is 2140, so centripetal force is 2140 newtons, what is the car's tangential speed? So I want to find dt. So now this is going to be easy because I already did all my conversions. I already found my radius. I know centripetal force is the mass times the centripetal acceleration because Newton's second law says F net is equal to ma. But I don't have the acceleration. But what I know is centripetal force is also equal to Vt squared over r because I know that centripetal acceleration is Vt squared over r. I did that in part A. So all we do is substitute this in, and now we have centripetal force is mv squared over r. Okay, so I want to solve for this. I'm not going to plug in. I'm going to rearrange my equation to solve for the unknown in terms of the known. So first, I'll multiply both sides by r. So FCR is equal to mvt squared. I'll divide both sides by m. So FCR over m is Vt squared, and then I'll take the square root of both sides. So I'm going to have the square root of FCR over m is equal to V sub t. Now I'll substitute in my values, including my units. So I have 2140. So I have to remember that a Newton is a kilogram meter per second squared times 518 meters divided by 905 kilograms. Now before I start plugging everything in, remember in physics, carrying my units through and canceling them is a foolproof way to check my work. So I see this kilogram in the numerator cancels with that kilogram in the denominator. But then this is multiplying, so underneath the radical, I'm going to have meter squared over a second squared. So I see when I take the square root of the number, I also have to take the square root of the unit, which will give me meters per second. So I see I didn't make a mistake. So when I do it all on my calculator, I see that this comes out to be 35 meters per second. So when I do it like this, step by step, I'm less likely to make a mistake. Just doing it step by step. And that's it.